Okay, what is a bubble sort algorithm? Bubble sort algorithm repeatedly swaps adjacent elements if they are in wrong order. When we are talking about wrong order, let's compare. Right order, when you count 1, 2, 3, 4, 5, 6, you will see it is in what? Ascending order. Okay, order of important value. Now looking at the wrong order now, 3, 5, 1, 2, 4, they are disarrayed. They are not in the right order. Okay, so now we use bubble sorts to arrange this wrong order into right order. So how can we achieve that? Let's look at the example. Given a list of 5, 4, 6, 1, 3. This is what? Wrong order. Okay, good. Now, what do we do? The bubble sort algorithm repeatedly sorts adjacent elements if they are what? Wrong order. So meaning 5 and 3 and 5, they are adjacent elements. So if they are in wrong order, it swaps it. It becomes it turns it to be what? The right order. However, 3 and 5, they are actually what? They are actually in the right order, right? So we move to 5 and 1. 5 and 1 are not in the right order. So it swaps 5 and 1 to 3, 1, 5. Okay? Now let's look at this example. We have 5, 4, 6, 1, 3. Compare the first two elements, that is 5 and 4. If they are in order, swap. If they are not in order, if they are not in right order, swap. Then the question is 5 and 4 in right order, in the right order? No. So what does it do? You swap. So swap them. Then from 5 to 4, we now have 4, 5, which is the correct order. Okay? These two adjacent first. After that you have swapped this, you move to the next iteration. You check since 4 and 5 are ordered, compare the next adjacent element. And which one is the next adjacent element? 5 and 6. That's the next adjacent element. Okay, now compare 5 and 6. Are they in the right order? Yes, they are in the right order because 6 is greater than 5. So nothing changes because 5 and 6 are okay. They're in the right order. That's what I mean by okay. Therefore, move to the next adjacent element, 6 and 1. Which one is the next adjacent? That's 6 and 1. Their next adjacent element. Here we swap because they are not ordered. Okay. So we flipped 6 and 1. Can you see the result now? We now have 4, 5, then 1, and 6, 3. Okay? Now also compare 6 and 3 until you are done with this value. Until you are done, you will move to the first element. So you have to, compare adjacent wise. Okay? So also compare 6 and 3, that is 6 and 3, the adjacent element. These are not order, hence we swap them as well. Swap them. Therefore, 6 goes into its space and 3 is adjusted to the place of 6. Okay, good. So you can see the third iteration gives us this result. Okay, now let's continue. The question is now is this list in order? No, because we still have 1 and 3 in between the list. Meanwhile, they're supposed to be at the front of 4. Okay, so what do we do? Since there is no adjacent element to 6, this is the last element to 6. We move to the first, that is, we compare the first two elements again. So which one is the first two elements? 4 and 5. 4 and 5 is the next element, and however, they are both okay. Then we move to the next adjacent value, that is 5 and 1. And since 5 and 1 are not in the right order, we swap them. So therefore, we have this iteration. We have this value 4, 1, and 5. Can you see it now? Then we have 3 remains and 6 remains. So what do? We compare the next adjacent element, which is 5 and 3. So compare 5 and 3, then swap them if they are not in the right order. Of course, 5 and 3, they are not in the right order, so we flip it, we change it, or we swap it. So we have this result: 4, 1, 3, 5, and 6. Okay, then we move again, we change the list. So 5 and 6, they are in right order, so we move to the first two elements again. Since the 5 and 6 are ordered, we move to the first two elements again, that is 4 and 1. So compare 4 and 1. Are they in the right order? No, these are not ordered. Therefore, swap them. Then we swap 1 and 4. Can you see? 4 goes to the place of 1, and 1 moves to the place of 4. Then we have 1, 4, 3, 5, 6. However, this is still not in order, so we compare. Also compare 4 and 3. So this is the next adjacent elements. Okay, these two adjacent elements, we have 4 and 3. These are not ordered, hence we swap them. Then we have 1, then 3, then 4, followed by 5 and 6. Now our list is in right order. Okay, so there's nothing to be compared again. Now the comparison ought, since all the elements are now ordered. Okay, so that's how bubble works. Okay, it compare adjacent elements, and if those two adjacent elements are not in right order, it swaps them as we have it here. Okay, now let's now implement. Let's look at it, how to determine the time complexity. The implementation using Python. Now in the implementation, this actual code, that when you use your code, this can be implemented using Visual Studio. Then we have Python, use Visual Studio, then store your Python interpreter, then it does that for you. Now giving a list of numbers, says this is a list of number we have here: 5, 4, 6, 1, 8. Then we initialize the variable. Now this number is the variable. Can you see? This is the code. This is called comment. Okay, this is called comments, so we don't need that. These are comments. Okay, they do not add to the program execution, just for the description, for the purpose of scalability and easy debugging processes. Okay, now any line of code that you don't have hash, these are real code. These are executable lines of code. Okay, now we have a variable called numbers, and we assign equals to me assignment operator. So we assign the list of the list of numbers, which are 5, 4, 6, as we have in this example we have here. Okay, so after then we compute the length of this list. What's the length of the list? 5. How? 1, count the element in this list. The element 5 is an element, 2, 3, 4, 5. So it's a 5 element. So we need that. We need the size of the number. That's how to get it. To get the list of the number, we use len. Len. Len is a Python built-in function that computes the length of a list and return it. So in this step now, the length of this list is 5. So what it does is that it assigns the size of the list, the size, having count it and sees that it's 5 in number, 5 elements in number, it assigns this 5 value to this variable called size of numbers. Okay, so this is a variable, then we assign the value we are getting here to it. Okay, now having gotten that, we iterate or loop through the list element. So what do? We loop through. Looping through means to traverse. We are traversing through this list. Okay, we are traversing through that list. So when you are traversing, we want to traverse within the list given us, not outside the list given us. That is why we need the size of the list. Can you see it now? Say loop through the list element. So for I in range size of n number, so in programming this is called iteration mechanism. Okay, iteration mechanism. So it's part of control structure. Okay, control structure in programming. So this is iteration. Iteration means when you need to perform an operation in nth number of times repeatedly. So we use iteration mechanism. One of it is for loop. For loop, we have while loop, we have do while loop, we have um, for while loop, for loop, and do while loop. Okay, etc. So but in Python we have for loop in this step. This is the structure, the syntax of it. So it has an integer here which is I. It could be any variable, but the conventional element we normally use for loop is I and J. Okay, but you can decide to use A, B, you can decide to use X, Y, and all. So for I in range, so this is the range. You have the 5, right? So this range takes 0 to 5. Meanwhile, the 0 is inclusive. Let me comment it. Let me put a comment. Yeah. So the range is 0 and 5, where 0 is inclusive and 5 is exclusive. Okay, so 5 is exclusive, therefore the value we are going to be having in this step is for the range is going to be 0, 1, 2, 3, and 4. And if you count it in a normal count, this is 5 elements. Can you see it now? So that is why we have this here. Okay, good. Okay, now we have a variable called swap. Then by default it's false. That is, we are nothing swap by default. So then we have another for loop inside the what? this loop. So this is called nested for loop, okay? And as you can see, it should be size of numbers, okay? So you will see that this size of number is reduced by what? By a constant 1, and of course by the value of I, meaning the range here depend on the value of I coming from the upper for loop, okay? So meaning the range of j is going to be 0 down to whatsoever 5 minus 1 minus I. So I could be any value at any given time. Could be 0, could be 1, 2, 3, 4, as the case may be, okay? Good. So this is where we determine the time complexity, because it's going to transverse through the loop in a number of time, okay? It's going to transverse in nth time here. The first loop is going to be doing that in nth number of time, and for the other loop is going to be doing that in nth, is going to be transversing, let me do this. So it's going to be transversing in this, since it depends on what? It depends on I. It depends on I. So the number remains n, okay? So we have nth minus 1 minus I numbers of time. Nth time. Can you see that now? So what you do is to multiply the time complexity that the first loop is going to be, traversing through the loop with the nth minus 1 minus I time that the nested loop is going to be transversing. So by then, you are going to be having, mathematically, having this n multiplied by n minus 1 minus I. Then this results into n raised to power of 2. Of course, can you see n times n means n raised to power 2, right? Good. Then minus n and minus n I. Okay, minus ni. It's multiplying all what we have in the parentheses, okay? Then we have this. So what do we do? From here, it gives us a quadratic equation. So what we are interested in here, the term we are interested in here is the terms that have the highest power, okay? The one with the high degree. So which one is the high degree here? The high degree of n here is what? 1. And of course here too is 1. But here we have it to be what? 2. So these will be the terms in that we're going to be using. And that term now turns out to be the time complexity, that is the highest degree of the quadratic is taken, that is n raised to power 2. Therefore, the bubble time complexity, the bubble sort time complexity is big O of n square. So that is it. If you have any question, you can reach out to me on WhatsApp. All right.